So I've got another question. My question is from Njabulo Zalo. So I see you've sent me question 5 and question 6. So question 5 is more kinetic molecular theory with a lot of stoichiometry, but question 6 is actually something very interesting. So here's a question. It says, the graph below shows percentage. It shows percentage yield. Now, this is a word that you don't really see much often, especially for chemical equilibrium. When we are doing stoichiometry or limiting and access reactants, then you will see this, the yield for this reaction. And it's so interesting because now they've also told us it's 30 kilopascal as the temperature is increased. So, and then they've given us a graph, and this is how our graph looks. I'm just going to write percentage like that. I'm a lazy person. And then we've got temperature on this side. And this is how our graph looks. It starts here. There are no values going all the way up. And then it comes to 30 kilopascal. So now, before we answer this question, I want us to look at it. So the graph below shows percentage yield. Percentage yield, this is what percentage yield means. If we are reacting something, right, we are able to calculate how much of that are we going to get. Is it going to be a good yield? Is it going to be a bad yield? When in the Haber process and they are trying to make ammonia, for an example, they are able to calculate how many liters or what volume of ammonia will be present in that system at that particular time. That is what we call percentage yield. Obviously, if a company is trying to yield something and they get 0.1%, that is not a good yield. But if it comes up to 88%, that means they're going to get more for the reactants and they're going to make more product, right? So that's what percentage yield means. And then at 30 kilopascal, when we say kilopascal, we're talking about pressure. So you see what the examiners are doing here. Instead of saying that the reaction at this pressure or whether pressure is being increased or decreased, they just write kilopascal. So you need to know that kilopascal is a measure that we use to measure a pressure. 30 pascal as the temperature is being increased. Now we need to remember when temperature is increased, going back again to the kinetic molecular theory, the particles are gaining energy. Collisions are going to be starting to occur and they're going to start colliding, meaning that we're going to get more product. So already you must have that in your mind. Now let's look at this percentage yield. At this pressure with this temperature, I'm going to read the graph like this. My percentage yield is increasing because if I was to give values for each of one like that, it's going higher and higher where it's touching the graph. I can already see if I was to give the temperature values, the temperature is also increasing as I move towards the right. So the percentage yield is increasing when the temperature is increasing. In chemistry and physical sciences, we call that directly proportional. So hypothetically speaking, if they wanted you to write or let's say maybe explain what is happening on this graph using correct physical terminology, you can say the temperature's percentage yield is increasing as the temperature is increasing, but it also has a little bit of vavavoom when you say they are directly proportional, meaning when one goes up, the other one goes down. When one goes down, the other one will also go down at this temperature. Then Njabulo's question further asks us, the question says, okay, the first one says, state Le Chatelier's principle. So we've already stated Le Chatelier's principle, Njabulo. If you have just joined us, Le Chatelier is a person who not really came up with the whole equilibrium system, but he's one of the few scientists or the scientist who actually came up with most of the things that we are learning now in terms of equilibrium constant and so forth, and that's why it is then named after him. So he did some good research in terms of chemistry to what we're learning today. So Le Chatelier says, if a system in equilibrium is subjected to a stress, the equilibrium will favor or shift in a direction which tends to relieve that stress. Remember, we can write favor or we can write shift, but the equilibrium never moves. Do not make that mistake. The examiners are going to give you guys trouble. And I mean, you don't want to, if this is for 3 marks, you don't want to lose all those marks and just get 1. So moving on. So in Njabulo, we've already answered Le Chatelier's principle. And then 6.1.2 says, now this is for 3 marks, the heat of the reaction let me summarize it here. The heat of the reaction, and remember, they show us or explain heat as enthalpy for the forward reaction, Now remember, the forward reaction could be anything. It could be products making reactants making a product, or it could be a product dissociating into reactants. Is positive. So now we must use Le Chatelier's principle to explain this statement. So the heat of the reaction, which is heat enthalpy, is forward, and we need to explain this. Now remember, if I've got delta H as a positive, meaning it's greater than 0, it is endothermic. Again, Le Chatelier tells us the system will shift in such a way, and you can see that this system is actually increasing as the percentage yield is also increasing. So it'll shift in such a way as to favor these conditions. And that is then why it is positive. So this is Njabulo Zalo's question.